Hi guys, so I want to make some clarifications at first in my last video. Well, I wasn't completely accurate in saying that the specific heat of water is 2.2 times 10 to the third joules over kilogram times degrees Celsius. That is the specific heat of ice, so to just clear it up, C of ice is equal to 2.2 times 10 to the third joules over kilogram times degrees Celsius. So this is a joule right here. Degrees Celsius. This is degrees Celsius and this is kilogram. And while C of water is equal to 4.19. Joules over kilogram times degrees Celsius. So those are our two values. Well, in the last problem, we already found out how much it takes to raise the temperature of the ice from -5 degrees to 0 degrees. But now we need to find out how much heat it takes to melt the ice in the water at water's freezing point, or its melting point now. Because the melting point of water is 0 degrees Celsius. Of ice is 0 degrees Celsius. So how do we do that? Well, we would use our formula. Q is equal to M times water's heat of latent heat of fusion. Why is it M times Q though? Well, if you remember the units for mass and Q, you get kilogram times joules over kilogram, and these cancel because the latent heat of fusion tells us how much heat is required to melt 1 kilogram of a substance from a solid into a liquid, and it also tells us how much heat needs to be removed for the liquid to be changed back to solid. So in this case, we would use the heat of fusion. And you notice that using unit dimensions, these kilograms cancel. So we have 1 kilogram, and the heat of fusion of water, latent heat of fusion of water is 3.3 times 10 to the 5th joules over kilogram. So once we plug in our values, we get something like 3.3 times 10 to the 5th. So this is how much energy is required for our second step of the calculations, which is the actual phase change. Well, let's find the last step. I need more room for the last step. Well, the last step, which formula would we use? We would use Q equals MC delta T, because we want to find out how much heat it requires to raise the temperature of the now liquid water to 10 degrees Celsius from 0. Well, plugging in our values, we get 1 times, because our temperature is in Celsius, so we use the 4.19, because that's the specific heat of water in its liquid form, times 10 to the third times 10, because we want to raise it by 10 degrees Celsius. And we get something like 4.19 times 10 to the 4th. Now that we found all the different amounts of heat are required for the different stages of our calculations. Remember, the first one was 1.1 times 10 to the 4th. what can we do now once we know all this? Well, we just have to add it. Or let's remove this stuff. So the total Q, or the sigma Q, is equal to 1.1 times 10 to the 4th plus 3.3 times 10 to the 5th plus 4.19 10 to the 4th. And these are all in joules. And if you use your calculator, these should add up to 3.8 times 10 to the 6 joules. So that's the total amount of energy required. So that's it for this video, and I just want to summarize it up real quick. This was the amount of heat required to raise the temperature of the ice to its melting point, from which it would melt into water. And it would have, so the temperature change would be from -5 to 0 degrees Celsius. And then this is the heat required for the actual melting of the ice in the water. And we got this from multiplying the mass times the latent heat of fusion. And the last value here was the amount of heat, which is a 4.19, sorry, is the amount of heat required to raise the temperature of the now turned water from 0 degrees Celsius to 10 degrees Celsius. So thank you guys for watching this video, and then please tune in for the next one.